Well, first, before I start on these achievements, I'd like to acknowledge the great mentorship I had from the late Professor Lee Seng Lip, who has taught me how to be a good engineer and a very good educator. And many of the achievements which I'm going to describe are basically done with the support, the great support of my faculty administrative colleagues, in particular my deputy heads, Professor Y.K. Chow, Professor Somsak, Professor Chan Eng Soon, and Professor Gary Ong. And so I will probably just say the achievements in the usual category of education and research. We were fortunate that during my tenure, Singapore was actually experiencing a construction boom. There was demand for engineering graduates, so we didn't really have the challenge that we face today in getting good students coming in to do civil engineering. In the education front, I would say that the three of my biggest achievements, one of it is actually the ability that we reduce our CEE curriculum by 20 to 30%, and this allows us to actually focus basically on fundamentals. In addition, the free time allows students a lot of self-study, which we encourage. We also, during my time, completed the accelerated master's program, which means that a student in the undergraduate doing the final year research project can continue to the master's if they want, so that you basically have both a bachelor and a master's within 5 years of your stay in the university. And the third achievement, which I probably would also felt that it was a starting block, was actually the overseas industrial program. We were able to arrange through our network with our local international partners here, putting our students in places like the Wallingford Hydraulic Station in England, with France's biggest contractor, Bouygues, who are the parent company of Dragash, and even to Japan, Obashi, as well as in Taiwan, T-Welin. And this was actually the start of most of our overseas industrial attachment that has continued under today. Now on the research, I think we benefited, as I say, from the construction boom. So there was a lot of programs that require us to actually play an active role in supporting Singapore's economic growth, particularly in development. Let me just quote 2 or 3 examples. First of all, the Center for Wind Resistant Structures. Not many people know that we actually had built one of the best wind tunnel that has aerodynamics capabilities. And this wind tunnel actually allow us to do simulation, CFD simulation for the construction of the Pinnacle. Not many know that the success of the Pinnacle, a lot of it is actually due to the efforts of our colleagues in the Civil Engineering Department. Let me say, for example, the Pinnacle is a 50-story building, one of the tallest, in fact, I think it's still the tallest public housing project in the world. The 7 towers are linked by 2 sky gardens and long bridges. These are something that nobody was sure that with our wind condition and all this, people up there will not be blown off, the place. And this was actually all modeled at the university. And with that also, the wind tunnel model has also done a lot of projects for the PSA, including how high can I stack the containers that will actually resist some of our wind conditions and so on, and the interaction between all the stacked containers on that part. As we start to grow on our public housing, our Center for Construction Materials and Technology play a very significant part in helping HDB to go into prefab, precast technology. For much of the precast use of precast in sunscreens, in the facade, in the construction are all done actually at our laboratories down here. Many tests went through it for accelerated curing, accelerated weather condition, weathering, heat and rain was all done down here. And it was because of that HDB is able to do a lot of those precast and technology into it. And we also work together, HDB, to set up the prefabricated technology center, which is still existing today. And the third one is in the area that, of course, my pet area, which is actually Center for Soft Ground. We actually built the Center for Soft Ground, and our first centrifuge that came in was very timely for us to actually work on the underground and tunneling problem in soft clay. So these are 3 examples on how we actually have contributed, the department has contributed to the developments of Singapore. Well, actually, it's all about students. What I was one of the memorable thing that I felt was actually the launch of the Project Orient. It was a project that started during my tenure that encouraged our students, to combine engineering with community service. I remember clearly the first project was actually to go to Batam to build a water reservoir, water for the people and the residents in Batam. And the question, of course, is on raising the funds for the students to go there and getting how do we transport all our equipment and all this. So we have to start to learn how to cover insurance of taking our equipment across to Batam. But more important is actually the students' own effort. And to me, working overseas ensures that our students are tested not just on the ability of the engineering, but how they adapt to the local conditions and materials, which are never the same as Singapore, where our materials are already supplied with all the equipment. They usually have basically to use the head to think, how can I use the local materials or local technology in building something that we take it for granted that we have equipment here to do it. And I thought that lecture learning experience was very good. And it's the same that every year I find the since Project Orient was launched, we actually have many community projects where the students were actually using very unconventional way of approaching engineering and yet get the solution done. And I credit that to the way that we train our students in terms of the thinking skills, in terms of technical skills that allow them to adapt. I think the right thing is adapt. I think our students also have actually benefited by understanding better that environment elsewhere is not the same. And I'm sure this will actually help them prepare themselves to be better engineers if they go abroad to do work and so on, particularly in areas that are emerging countries that doesn't have the kind of technology that we have present today. The second example, which I think is equally memorable, is the department was the first to actually meet a physically challenged student and who is actually wheelchair bound because of a car accident. It's unfortunate. But she actually always aspired to be a civil engineer. And when the parents actually approached me to see whether we can actually accommodate I thought it was one that in the university we rarely in the past accommodate people physically challenged before inclusivity becomes a norm now, okay? In those days, we actually start to look, and I brought all my deputies together now, how can we make sure that the student can comfortable do the work? So I have a great support of Professor Somsak, who look at all the curriculum where the students that undertake for the 4 years. How can we actually move some of the venues to more accessible areas? Because we had to see how she comes from the home, and fortunately the university provided a van that transport them around when we had to change classes. But we need to start from that first beginning now. Starting at the level of the lift, how does she go and where else she has to go to be accessible. And naturally, we even have to have interim access like ramps and all these for that student to actually be able to access not only the classes, but the amenities as well. But the most heartwarming part that I felt was the students mobilizing themselves. And these students basically were able to mobilize themselves as buddies. And these buddies actually, they help to actually take care of him between classes, bring her to the toilet, take her to the canteen, which I thought was very, very useful and important. So this is very heartwarming to me. And the final satisfaction really that comes is that one, the student graduated, received a standing ovation in a commencement. And of course she graduated and she started working for the father's engineering company. So actually it's basically that we have actually contributed in having one engineer, but more so that we actually allow a person who has a passion for civil engineering to be able to actually complete her aspiration. I think the greatest challenge, and all of us are aware of, is actually the difficulty in attracting students, both in quality and quantity, to the department. It's not an NUS problem. It is not a Singapore problem. It's actually a global problem that people are now finding, the civil engineering industry or the construction industry to be less attractive. And to me, this is the biggest challenge. And one of the ways I've been thinking many, many years already, because I've been involved not only as the head of the department, but I'm involved also in the industry and also in several government advisory committees and capacities, how to actually make engineering become more attractive. I come to the conclusion that really we have to reinvent civil engineering, and we have to actually rethink, not by doing small little fixes and hope that the problem will go away, but actually a bold transformation. Now, have I reached the journey yet? Not, because our ecosystem and the construction industry is a very complicated system in Singapore, particularly with all our subcontractor system. But I have this belief that we really have to take it very boldly, transform it in a way for us to be able to attract more people to come in. I've seen some good success in certain places, particularly in contractor, when they start to move into areas of using AI and remote control into their work. It attracts a new breed of engineers that not only knows about civil engineering, but also is very strong in IT and AI. For example, now you don't need to go underground. You don't have to send people to do underground construction using tunneling. Tunnels in the underground in Japan, they all control actually at the top of the site office, and they can see everything that's going on. They control it by remote control, and actually these are the way that I think we have to really reinvent the industry for us to attract a different breed of people. They always feel that why are they doing hot things in the sun, underground dirty work. None of this need to be dirty in underground if we actually use our imagination on how to reinvent civil engineering, how to construct them. We cannot push away this problem because as long as the country is growing, and that there will be developments, and with that developments means that you need civil engineers, you need all engineers, but I think you need civil engineers, particularly in the built environment. So I think the work in terms of work is not a problem. It's how do we make the work attractive and rewarding from the people for who's going to come into engineering. One of the things that I'm trying to do is also how can I change the salary of engineers to be no different from those in the AI and IT, so that if you're well paid, there's no reason why people will not come in. If you provide the right conditions, if you provide for an IT engineer, an AI engineer, why can't they actually want to work into this? So this is something that I think we should, because the work of the engineers, particularly civil engineers, is for everybody to see. Everywhere you walk into, all the built things are actually all done by engineers, civil engineers particularly. Well, I'll say that engineering is a very versatile profession. Particularly the training in civil engineering allows the fact that we focus on technical skills, problem solving, analytical skills. All these actually attributes that is necessary in any kind of work that you do, both engineering and non-engineering. My sense is that our training actually allows our graduates to choose different pathways in engineering roles and non-engineering roles. My sense is that we should not always just think that at the end result is a traditional engineering. No. I've seen engineers that actually have done well and succeeded in many areas in non-traditional. Of course, we also would like to see many of our engineers succeeding in the traditional roles. But that is the beauty of our training, We train people to think analytical. We train them to actually think in a way of problem solving. And you go to any organization, these are the two set skills that they want. Doesn't have to be all about civil engineering, but it can be in any areas that be finance or anything else. And I thought that really my advice to all these graduates is never limit your opportunities by taking the only thing that is a traditional way. I think the training that you have allows you to explore immense opportunities in the world now. Civil engineering is everything that you see that is built around us. The department has produced thousands of engineers. They've actually contributed the transformation of Singapore from a fishing village into a cosmopolitan city-state, resilient and developed, with infrastructures that drives the economy and buildings that optimize our land use. We should be proud of our alumni that has taken a role in this development of Singapore in a very successful way, not only for the city-state, but also for the region around us. Happy anniversary, CEE.